Today we meet again in our online class. We will continue our class in chapter 2, part 3. Part 3. Okay. Okay. So chapter 2, part 3, transmitter. The learning outcomes. The student should be able to draw block diagram for several types of transmitter and explain their operations. Okay, we are talking about the transmitter, transmission, and the operation of parts of this transmitter. In spite of wide variety of uses for transmitters, from toys to broadcasting transmitters, there are only a few topologies that are used in their design. So first we will discuss about transmitter requirements. A transmitter must generate a signal with the following criteria. Okay, these are the criteria for the transmitter signal. First, correct modulation types. Second, it must have power, sufficient power. Third, must generate at the correct carrier frequency. Okay, frequency carrier, power, modulation. And fourth, should be efficient. So we have four criteria, important criteria for the signal of the transmitter. First is modulation type. Second is sufficient power. Third is carrier frequency must be correct. And four, it should be efficient, sufficiently efficient. Okay. Okay. The frequency, accuracy, and stability. This is about the transmitter. First, the frequency, accuracy, and stability. The accuracy and stability of the transmitter is fixed by the carrier oscillator. Exact requirements are determined by application of the transmitter and by regulatory bodies or regulation agency. Okay. So what is the problem here? The requirement, exact requirement are determined, exact requirement of the frequency. The frequency. Now we are talking about frequency in kilohertz, megahertz, right? So the accuracy and stability of the transmitter frequency is fixed by the oscillator. So the oscillator determine the frequency. Exact requirement are determined by application of the transmitter and by regulatory agency. So how we determine the frequency is determined by the application or the use of the transmitter and also by the agency. the regulatory agency, penguatkuasaan undang-undang. Okay, so this picture shows to change the wavelength, grind down the crystal. So now you have the crystal for oscillator. Okay, so this crystal basically determine the frequency of the transmitter. Okay, second is frequency agility. Frequency agility is the ability to change operating frequency rapidly without extensive retuning. Okay, what is agility? Agility is ability to change the frequency rapidly without extensive retuning. Broadcast transmitters are rarely retuned. Other services such as CB is citizen band. Band radio. Other services such as citizen band radio require rapid and accurate retuning to other channels. Okay, if you want to know further about this, Google lah. Okay, Google. What is citizen band radio for Malaysia? The third issue is spectral purity. Spectral purity is a measure of the spurious signal generated by the transmitter. All transmitters generate frequencies other than the carrier and the sidebands required for modulation scheme in use. All frequencies except the assigned transmitting frequency must be filtered out to avoid interference with the other transmission. Okay, so all transmitters generate frequencies other than the carrier and the sidebands. Okay, so the transmitter also generate other frequencies. Okay, other frequencies than the carrier, meaning that this transmitter also generate other frequencies besides the frequency of the carrier and frequency of sidebands. Okay, because normally in AM modulation you only discuss about the carrier frequency FC and sidebands. Okay, USB and LSB, right? Still remember this? Upper sideband and lower sideband. So other than this frequency, there are other frequencies which also generated by transmitter. So all these frequencies must be filtered out to avoid interference with other transmission. Okay, so just ignore this one. Okay, power output. Number 4 is power. There are a number of ways to measure transmitted power. Okay, in previous slide we have discussed about calculation of the transmission power. Okay, P total, P carrier, right? You still remember PT, P carrier, plus. Okay, so there are a number of ways to measure transmitter power depending upon the modulation scheme employed. Transmitters for full carrier AM are rated in terms of carrier power. Okay, P carrier. Suppressed carrier AM transmitters are rated by peak envelope power. So we have discussed about this also, peak envelope power, PEP. FM transmitters are rated by total power output, total power, P total. So there are different naming, different, dipanggil apa? Different scheme of power, carrier power, peak envelope power, and total power. Depending on the modulation scheme being used. Okay. Then efficiency. There are two important reasons for efficient transmitter operation. There are two. Number one is, most obvious is energy conservation. So normal. So we need to use, this is about energy conservation. Okay. Power that enter the transmitter but does not exit via the transmitter output is converted into heat. So this is loss. So basically, energy conservation is we call it general rule. Okay, so P energy is not created and is not, what is that? I forgot already lah. Energy conservation, tiada tenaga yang diciptakan. Tenaga, the energy is changing from one form to another form. Okay, that is basically lah energy conservation. So the power that enter the transmitter but does not exit via the transmitter output is become heat, which is loss. Large amount of heat requires significant amount of additional hardware to remove the heat, adding to the cost of equipment. So for us, we need to in order the system to become very efficient, should the power input should be equal to power output. But in reality, some of the input power will become loss. Okay, so in order to reduce or minimize the loss in terms of heat, so we need to add some equipments in order to reduce or to minimize the loss, the heat. Okay, next is modulation fidelity. An ideal communication system allows the original information signal to be recovered exactly except for a time delay. Compression is often used to raise the overall modulation level of the signal. Compression distorts the overall dynamic range of the original signal but results in an improved SNR ratio. Other types of distortion, such as intermodulation and harmonic distortion, must also be kept at minimum. Okay, so we stop there. Okay, we stop there. That's all for this video. Okay, there are small distortion outside. Okay, see you later after this. Thank you very much.